It began with a flash, a streak of light racing across the Siberian sky. For a brief moment in 1908, it looked beautiful. But what came next flattened 80 million trees over an area the size of a major city. The Tunguska event, as it came to be known, remains one of the most powerful explosions ever witnessed on Earth. And it wasn't caused by a bomb, or a volcano, or even lightning. It was caused by something far smaller, a rock from space. That single event, over a century ago, serves as a chilling reminder that our planet drifts through a cosmic shooting gallery. The vast emptiness of space isn't as empty as it seems. Countless fragments of rock, ice, and metal, known as near-Earth objects, or NEOs, silently orbit the Sun, and from time to time, one of them sets its sights on us.
Most are small. Most burn up in the atmosphere, no more dangerous than a shooting star. But every now and then, something bigger comes along. Something that doesn't burn up, something that hits. 66 million years ago, a space rock about 10 kilometers wide slammed into what is now the Yucatan Peninsula. The impact unleashed the force of 10 billion nuclear bombs, setting forests ablaze across continents and triggering a global winter that wiped out 75% of all life on Earth, including the dinosaurs. That asteroid, now called Chicxulub, changed the course of evolution forever. But here's the unsettling truth. There's nothing stopping it from happening again. Every year, astronomers discover thousands of new near-Earth asteroids. As of now, we've identified more than 35,000 of them, and we're still finding more every week. Most orbit safely away from our planet. Some, however, come dangerously close, within a few million kilometers. In cosmic terms, that's a near miss. Take Apophis, for example. In 2004, scientists discovered a 370-meter-wide asteroid on a trajectory that appeared alarmingly close to Earth. Early calculations even suggested a small chance of impact in 2029. For a few tense weeks, the scientific community held its breath. If Apophis hit, it could flatten an area the size of France. Later observations ruled out an impact, but the asteroid will still pass closer to Earth than some of our satellites, a mere 31,000 kilometers away. You could practically wave at it. And Apophis isn't alone. There's Bennu, a half-kilometer wide boulder drifting through space, with a 1 in 2,700 chance of hitting Earth in the late 2100s. Then there's 1950 DA, an asteroid with enough mass to cause continental devastation if it struck, predicted to pass worryingly close in the year 2880. That may sound like the distant future, but the clock is always ticking. The danger doesn't just come from the big ones either. Sometimes, smaller asteroids slip past our defenses entirely. In 2013, a 20-meter meteor exploded over Chelyabinsk, Russia, with the energy of 30 Hiroshima bombs. Windows shattered in thousands of buildings, injuring over 1,500 people. The asteroid came from the direction of the sun, completely invisible to telescopes. No one saw it coming. That's the terrifying part. We're not always prepared. Despite our technology, we've only mapped a fraction of all near-Earth objects large enough to cause regional destruction. NASA estimates that we've discovered about 95% of the planet killers, objects a kilometer or larger, but only around 40% of those capable of leveling a city. The rest are out there, hidden among the stars, waiting to be found. So what are we doing about it? For decades, scientists have been racing against time, developing ways to detect, track, and, if necessary, deflect incoming asteroids. The Planetary Defense Coordination Office, yes, that's its real name, keeps a vigilant eye on the sky, using telescopes from Earth and space to catalogue every suspicious rock that crosses our orbit. But detection is only the first step. In 2021, NASA launched a mission straight out of a sci-fi movie. The DART spacecraft, short for Double Asteroid Redirection Test, was sent on a one-way journey to crash into an asteroid moonlet named Dimorphos. The goal was to see if humanity could change an asteroid's path. When DART slammed into its target at 22,000 kilometers per hour, it actually worked. The impact shortened Dimorphos's orbit by 33 minutes. It was the first time we've ever deliberately altered the motion of a celestial body. It proved something extraordinary. We can defend ourselves. But DART also revealed just how difficult that would be in a real emergency. The asteroid was chosen precisely because it wasn't a threat, and it was relatively easy to reach. In a real-life scenario, we might not have years to prepare. We might only have months or weeks, and the asteroid might not cooperate. Some are loose piles of rubble rather than solid rock. Hitting one might just scatter it into multiple deadly fragments. So we keep searching and simulating and building better systems. Ground-based telescopes like Pan-STARRS and the Catalina Sky Survey are scanning the heavens every night. Soon, NASA's NEO Surveyor mission will launch, a space telescope dedicated solely to hunting asteroids in the infrared, capable of spotting those sneaky ones coming from the sun's direction. But as with most things in space, certainty is an illusion. For all our progress, we still rely on luck. And luck doesn't last forever. Imagine this. It's a quiet night. The observatories are humming, data streaming in as usual. Then, a faint object appears in the sky, moving faster than anything else. Within hours, the orbit is calculated. Within days, the news breaks. A 200-meter asteroid, due to impact Earth in less than a year. Not large enough to end civilization, but enough to destroy an entire nation. What do? Launch a deflection mission? Evacuate millions? Hope it burns up? The truth is, no one really knows. Asteroids are the ultimate wild cards, relics from the birth of the solar system, carrying both the seeds of creation and the potential for destruction. They remind us how fragile our world truly is, suspended in the black void of space. But there's a paradox here. The same objects that could annihilate us also hold clues to our origin. Asteroids carry the building blocks of life: water, carbon, organic molecules, the very ingredients that may have jump-started biology on Earth billions of years ago. In that sense, they're both destroyers and creators, cosmic messengers from a time before humans existed. We study them to understand our past, and we fear them because they might decide our future. The Tunguska explosion, the Chelyabinsk meteor, the shadow of Apophis. They are not warnings from the universe. They are reminders. Reminders that in the vast cosmic ocean, we are not invincible, and we are not alone. For now, the sky remains calm. But every meteor that streaks overhead, every faint glow across the horizon, whispers the same question: what if the next one doesn't miss?